let's go ahead and get started then. So,
Yeah.
the first question I want to ask you here, by the way, first I want to say this. Welcome to the mock interview. I'm getting ahead of myself. Welcome to the mock interview. The format here is gonna be we're gonna do 1 hour. All right, we're gonna go straight to the problems. We're gonna do 45 minutes or so of the problems, and then we'll have 10 minutes, 15 minutes at the end for feedback and questions. All right.
All right.
Okay, cool. What's your preferred language? Is Python your preferred language?
Yeah.
Okay, cool. So for this problem, I'm gonna read it out, and then I want you to stop me if you have any questions, any concerns. All right, like kind of like a whiteboard interview. All right.
Yeah.
So this problem is called group anagrams. Have you heard of it before?
Yeah.
Okay, then we'll do a twist on it. That's okay. So let me give you the problem definition at the start. Okay, so your input is going to be an array of strings, and I want you to return me a list of lists, and in each of those lists are all the words which are anagrams of each other.
Anagrams of each other.
Yep.
Okay.
If you know the
So
problem, then we can
that's
just get started in there. But yeah, please direct me. Please walk me through the problem.
so first off, do you have like an example input output?
Yeah, I can provide you with one.
Cool. So we basically want to group the anagrams together. Um, so I believe an anagram means like they contain the same amount of characters, right? So two things are like Nat and Tan are anagrams because if you sort it, right, they're going to provide the same output.
Uh huh.
Also, if you were to implement like a counter based on the characters, you will also again get the same output. So
Okay.
comparing those two will tell you that they are similar, if that makes sense.
Okay.
Um,
Yeah.
right. So I guess like the most like naive solution we can get into is um, just take a word uh, and then just compare it to every other word, and then decide if they're anagrams of each other, if that makes sense,
Okay.
right? So in terms of uh, complexity, uh, you're comparing each word to every other word, right? So at the very least, it's going to be like n squared. Um, I
Okay.
think
What's in here? Can you quickly define n?
and in the sense of like each word,
So like n is the number of words.
yes.
Okay.
Um, right. So like an optimization we can make again. So we said that we can sort and also we can count the number of characters in a word. So I guess one thing we could do is uh, maybe have like a dictionary, right?
Okay.
Where your key is going to be like the output from the counter on a given word. So, for example, the key for the word bat may look like B to 1, A to 1, T to 1, right?
Okay.
This and essentially we would have this key, and then for the values we would have a list defining like which words have this key. So then this would have something like this, right? So for this example, um, you would have something like this as your dictionary.
Okay.
If you, does that make sense?
Yeah, that makes sense. And what will this dictionary be responsible for? Like, where would it be stored?
So the whole point is that by doing this, we would essentially go through our list of strings, right? And as we go through, we are building our solution. So at the end, the return is going to be as simple as dict.values. We just return this, and it should return a list of lists where each list contains grouped anagrams.
Okay. Yeah, I see that. All right.
Right. So does that implementation, that makes sense, right? I
Yeah.
don't, yeah, cool. So, right, just to go through like the basic pseudocode, I guess. We for loop through our input, count characters for each element, and then store element in dictionary based off the counter. And then in the end, we we output the values in our dictionary. So, any comments?
No, that makes sense. Let's look the implement. Yeah,
Okay.
let's do the implementation.
Okay, cool. So I'll just all our dictionary just result array. In terms of the key, I think I'm gonna call this like a frequency array. Essentially what this is it tracks how many of each character we have. So this should result in like an array of like 26, where, for example, our first index is going to represent how many character A's we have seen for our given word.
Okay.
Okay. Now we're going to go through the characters and we'll increment our counter. So let's see. Actually, instead of this array, I'm just going to make things simpler for myself. Just going to use a dictionary. Dictionary will have, let's see, something like that. And then in the end, we can return our values.
Cool.
Cool.
So
Let's see.
So I have one question for you here.
Right.
So we're using the frequency map as the key of a dictionary.
Right.
Is that allowed?
It may not be.
Do you have any like ideas as to why or why not?
Just, I guess. Actually, this is my first time trying this implementation. I believe when you have keys, your keys have to be, I think, immutable, right?
Yep.
Right. So if we used like an a list, for example, we would have to convert it to a tuple before we pass it in as a key.
Yeah.
Not actually sure how that would apply for a dictionary. Um,
Yeah, dictionaries are also mutable, so they can't be used as keys.
I see. Yeah. So what type of, I guess, yeah. Okay. I think what I'll do is I'll go to our initial like idea with the the frequency like list, and in the end we can convert this to a tuple before we store it in our result. Uh, so the reason I wanted to switch to a dictionary is because I'm not sure if this calculation is correct. Uh,
Okay, can
the
you walk me
basic
through?
idea, yeah. So the basic idea of this calculation is that we're using like the ASCII character set.
Uh huh.
So if you have a character I forget the exact value for the ASCII symbols, but right, so like a character A might be assigned to like
It's 97.
65 or something, right? And then if your character over here is the character A, then essentially you'll get like a 65 minus 65, right? And that will give you the value 0. So in our 0th index for that frequency array, it would get incremented by 1.
Okay. Can you
Uh,
can you use the letter B as an example?
so if you have the letter B, what would happen? If you have a letter B, I believe the ASCII character just changes by 1. So we're going to have a -1. So this wouldn't work because then we're incrementing the very last character, right? So A becomes index 0, whereas B becomes index -1.
What in,
This
what index do you
could,
want B to be in?
um, I want it to be at 1.
Okay.
Uh, or the other way around is fine as well. So if we have A at index 25 and B at index 24, that could work as well. So then maybe we could try something like the ASCII value of Z, and what would happen is that maybe Z has the number 65 plus 26, right? And then when you subtract A, um, you're subtracting 65 from that value. This should result in something like the index 25 or the 26th character in our frequency array. Now we increment that by 1. Um, does that make sense?
Okay, so
So
we
then,
have A at index 25 and Z at index 0.
exactly.
Okay, that's fine.
Yeah, cool. So now this should be fine. Um, and then lastly, as we discussed before, we need to convert this to a tuple. And yeah, and our return value shouldn't change.
Okay. All right. Can we do a quick time and space analysis, please?
Cool. So what we're doing here is, first off, I think we can say that like the frequency array, we're using all of one space here because each we're resetting the frequency array, and there's at most 26 characters. We're looping through words. We said earlier we said that n is equal to num words. Then over here we're looping through characters. We can say that C can be equal to num characters, like at the worst case. So if you have like we're considering like the biggest word in our word list. So this operation takes O of C time. So altogether, the time complexity comes out to O of C times n. In terms of space, so this is going to take up O of 1 space, and we are also storing a dictionary of lists. And within this dictionary, we're gonna have n words, and then at the worst case, C characters. So we're using O of n times C time and space for this algorithm.
Okay, that makes sense. All right, so I want to move to a follow-up now. All right, so for this follow-up, what I'd like us to do is to keep the same logic. So the logic you have here, let's assume it's correct going forward. But we now want to change this into a streaming algorithm. Okay, so what does that mean?
Okay.
So I want you to write me a class called anagram grouper. All right, so you can take some notes here. All right. And then it's going to have a constructor, so you can decide on what to put there, okay? And then it needs to support a couple functions. It needs to support add. So add, it will add a word, right? So the add function takes in a word. It needs to take in a group. This is a different function. This is a different function. So the separate function is called get. So get group. Get group will take in a word, like another word, and it will return all words that have been seen before that are anagrams of this word, this input word, right? And then there's going to be get all groups, which is to return what we had previously, a list of lists, where each list inside are all words that are anagrams of each other. So that'd be the last function, get all groups.
Sorry, somebody called my phone and.
Yeah, no worries. Where did you leave off? Get group. Does get group make sense?
Yeah, get group returns all the words in that
That's
input
correct.
words group.
That's
right?
correct. Well, that word that is input, it might not have existed before. Okay. So it's not specifically all words in that words group. It's all words that would be in that words group.
Okay.
Right, if it doesn't exist, because it might not exist yet.
Sounds
and then
good.
The last function you need to implement is get all groups. And get all groups does what we did previously, which is that returns a list of all the anagrams.
Okay. So this wouldn't take any input, it would just return what we have stored.
That's right.
Okay.
Yeah, that's all for now. Please implement this.
Okay, so let's think about this. So we already have get all groups done. In terms of get group, what we can do is go through this entire operation again, and then just return our dictionary, like the value associated with the key that we produce from like our frequency map. So I guess a question, do we want to place this word inside our resulting list, or do we want to store the word at all? Or does that only happen when we add?
Yeah, that only happens when you call add, yeah.
Okay. All right. And then add word, is it fair to say like, if the word is already added, we can just ignore the call?
No, you need to store multiple versions. Like more than one quantity.
What does that mean? Like, so you would have two of the same words?
Yeah.
Okay. Um, yeah. So that means that we can have duplicates in our like resulting list. For example, when we get group, it's going to have duplicates, and that's fine.
Yeah. Well, yeah, that's fine.
Okay. Um, yeah. Okay. So let's see. So add word. We go through this entire process we did per word in our initial function implementation. Um, yeah, so it should be like very similar in terms of at the pseudocode at least. When we in our constructor, we would also want to initialize our dictionary, which will have the exact same mapping of just the frequency or the count of characters for the word to the list of words. Uh, Get group, um, we search our dictionary and we return the list of words. And then get all group again is just we get all groups will just return um, our dictionary stuff values. We just return that function.
Okay.
If does that make sense?
Yeah, that makes sense to me. Yeah.
What did we want to call this class again?
Anagram grouper. Very creative, I know.
um, this might not be a great name for our data structure, but change this later. It's this error. Okay, let's see. Station. Are we returning anything when we add?
You don't need to, no.
Okay. Okay, so this is our initial implementation. Uh,
Okay.
how does this look to you?
Looks fine. I see some duplicate code though. Maybe you can factor that out.
Let's see. So we're duplicating our character frequency. We could take this out, just place it in like maybe like a counter function. This will take in a word.
Okay, nice. Looks better.
Cool. Yep.
All right, now I want to implement a remove function. So remove also takes in a word, and it removes um, all instances of that word from your state.
Okay, so this is an interesting addition in the sense that a remove is gonna be pretty expensive. Like the most naive implementation we can do based off what we have so far, right, would have us maybe getting the frequency and then looping through our our list for that frequency and then removing that word. Uh, and so in the worst case, what could happen is that um, that the list might just have only that word we're trying to remove. So then if you go and remove every single character one by one, what can happen is that, well, what will happen is that the removal will take n squared time into one, like n is like the list of words that we have associated with this frequency key. Does that make sense? What I just said?
I think what you said made sense. I missed a couple of
Right.
details about at the end there, but I think you can go ahead. Yeah.
Right. So yeah, just to reiterate, I guess, the initial solution, right? You calculate the frequency.
Yep.
You calculate the frequency. Um, sorry, just thinking. So we calculate the frequency, we get the dictionary value. It's going to return a list. In the worst case, in this list, every single value can be a duplicate. Just be dupes of the same word. That word is the word we're trying to remove. And we would loop through this list and remove every single one. This is going to take O of n squared, which is not very fast.
Why would it be n
So
squared? Can you tell me about this?
because let's say we're trying to remove the word like cat, for example.
Okay.
Right, our list would just be a bunch of cats with our current implementation.
Okay.
And right, so we're looping through this list. We're trying to remove the first one. It's gonna look something like this. So then everything is gonna be moved back by one. I believe that's how like the Python arrays work.
Oh, I see what you mean. Okay, okay. No, I got you. Okay, in that case, you're correct. Okay.
Yeah. So what I'm thinking now is, since we still want to, so if we didn't allow dupes, it would be as simple as, storing sets instead of lists, and then we just set dot remove. But since we do allow dupes, what we can try doing is, instead of a list of words, we can have a dictionary of words. So that would look like something like this. It's like, for the key cat, we'll have the value 3. This indicates that we have 3 cats, right? And then when we delete, we just remove it. And it should be as simple as that. The reason we want to have this dictionary is that when we do this get group calculation, essentially what we would do is we would build the return value. So if you have a dictionary that says something like this, like cat to 3 and then dog to in runtime, we're going to build this type of array. Does that make sense?
Yep, that makes sense. Yep.
Cool. Yeah, so similar to this character counter, we would probably want that builder. So let's let's just have this function defined, but we won't worry about the implementation for now. We'll come back to this, but we'll call it like a result builder or something.
Okay.
So then in terms of removal, you'd get the frequency again. And then would be self.ngrams. We'd pass in the frequency. And then from that, we would pass in the word. And then we'd delete this. And this would be our remove function. But now we would need to update a few of our other functions as well. So
Okay.
to start, not sure if, never done this before, I'm not sure if this is like something we're allowed to do. Do you know if this is allowed?
Yeah, you can do that.
Yeah, it's just, okay.
Wait, what happened to your Oh, I see. You just changed the date. Okay, okay.
Yeah, I'm honestly not sure how they interact, but it was giving an error.
Okay. I actually think it should work, but I didn't see the error.
I can bring it up again. But yeah, I'm not sure how this interaction works.
Oh, really? Wait, did you import it? You did. Okay. Oh, okay, that works. Okay, maybe you need a lambda there. All right.
That's new syntax for me. I'll look into it after. But yeah, so we get the frequency and then we get the word, and then it should be plus equal 1. When we get the group, we get a frequency, and then we can call this result builder function that will ideally return a list of and we can return this for
Yeah,
our
yeah,
get
yeah,
all
yeah.
group.
Yeah, I think
Yep.
that should be fine. Yeah.
For get all groups, we do need to change this implementation as well. So I believe another result array, and then we can do through this value. So we'll do something like this. And I believe like Python has this type of syntax where we can like concatenate list this way, if I'm wrong, but I should be able to do this.
Yeah, there is that syntax. Yeah, you are trying to. Yeah, okay. No, that should be word. Yeah, that should be fine. I think it's unhackable right
Wonder
now
what.
because you're just passing result builder instead of like returning a dummy. Like,
Right. Okay. Oh, I see. That makes sense. Okay. So for this, we should be able to read through our dictionary like this. Items, and then cool. So I believe this should work now.
okay, yeah. Yeah, I'm pretty happy with that. Let me just quickly think about what I want to ask. Um, can you tell me about the space usage of this class?
Um, so the space usage, in the worst case, it should still stay be the same, I believe, as our initial like group anagrams algorithm, because we're storing every single word that comes in through our streaming. As we stream, like we store every single word that comes in. And in like the worst case, we wouldn't remove any of those words,
Yeah,
if that makes sense. And then
yeah,
throughout our different functions, we do use additional space, but that additional space in terms of time complexity, it's not worse than the total amount of words that we store. So in terms of space, the time complexity is still the same as our initial algorithm.
yeah. And can you tell me the best case space efficiency compared to the previous solution?
The
For example,
best
if I ask
case.
you another way, if I ask you another way, it's what input would you like? What would save the most space compared to the
One
old solution?
input. So in terms of storage, I think the biggest change we've made is that we're using a dictionary now instead of the array. So then imagine like a case where um, we deal with a lot of duplicate words. Previously in our array, um, you would have a word per you would have an entry per word that comes into our application. But now, in terms of space, we store each unique word, right? So if you have
Yes.
a list of, let's say, length 10, but has two unique words, our array implementation would store 10 elements, whereas in our new implementation, you would store two elements. So in the best case,
Yeah.
uh, we store um, in the worst in terms of complexity, we store the number of unique words.
Yeah. That's right. Okay. All right. And then for my last follow up question, this is going to be a thinking exercise. So it is a coding problem, but I want to just we don't have time for that, but I want you to just walk me through how you would approach this. All right.
Yeah.
So now I want you to support another function called get smallest group by number of items in that group.
Okay.
Okay. So how would you implement that?
Um, so let's think about this. So we can get a group based off like the frequency key, right? Um, so trying to think. So we want to get the smallest. Um, so immediately I'm thinking about heaps because if you have a min heap that's based around the number of words that you store for a given frequency key, you can get the minimum value in of one time. Um, really now what I'm thinking about is how would we organize this heap, right? So when you add a new word, um, your heap needs to reorganize itself. Um, so I'm not sure actually if we could use heaps here because either we can, but it would require a lot of like logical implementation. Like it
Yeah.
wouldn't be a clean solution if that makes sense.
Yeah,
Um,
yeah. I mean, you could definitely use heaps as a solution. I'm curious what other possibilities you have thought of.
what other possibilities? So the most straightforward thing you can do is just uh, call this call our dictionary, loop through the values, and just count, and just return the smallest value we see.
Okay.
Um, you could make that even faster if for a given frequency key, alongside the dictionary, you also store the number of words. That way you don't have to go inside like the inner dictionary to
Yeah.
find out how many words are stored, if that makes sense. So then it would just be like you would look into you would look into uh, like the state variable that defines how many words we have for this frequency.
Yeah.
Um,
Okay.
for that, in the worst case, we would be looking through every single unique frequency our streaming application has captured since start time. Um,
Yeah. Okay. That's yeah. Um, I guess how do you compare that with the heap solution? Like the
with a heap
solution.
solution,
Yeah.
so let's say like we find a way to um, organize the heap based off the number of words we add and the number of removals we have. Like let's say like we figure out how to like organize the state of the heap, then like the solution would be as simple as just like peeking into the top of the heap, and we just return that value.
Okay. And
So that would
between
be
these
enough. Yeah.
and between these two, which would be simpler to implement?
Um, our like the initial solution where we loop through all of our frequency keys would be simpler to implement. We wouldn't we might add like a new state variable, and we would need to um, tweak that variable around throughout our different functions. Um, but after that, it's as simple as just looping through this anagrams dictionary.
Okay.
Whereas for heaps, I couldn't actually tell you how we would manage the heap off the top of my head. I would need to give it some thought.
Okay. Okay. That's fair. No, I think those are acceptable answers, so I'm happy with that. Um, all right, let's end the interview here,
Okay.
and let's go into the feedback and questions.
Okay.
Okay, so first thing I always ask people is, how do you think you did today?
Um, I think I did pretty good, I would say, in the sense that I think I communicated my thoughts pretty well to you.
Yep.
I think
Yep.
like I wasn't very like good with like Python specific like knowledge in the sense that I don't know how to use lambda functions, for example, or I forgot about the immutability requirement for dictionaries.
Yeah.
Um,
Okay. Yeah. Yeah.
and it,
That's a. Don't feel too bad about that. That's a very common gotcha people fall for this question. So you're definitely not alone. You're definitely not the first one. You won't be the last one either. Um, would definitely recommend, of course, you just polish up a bit more on the Python aspect, um, especially when you're using it for interviews. I mean, to be fair, I think you know a good amount for interviews, no problem. But there's always more you can learn, right? So
yeah.
so just make sure you're brushed up on that part. Um, yeah, I mean, I think you also did pretty good today. So pat yourself on the back, pretty good performance, nothing major, right? Overall, you were pretty good at like you had a pretty decent pacing. You had good ideas throughout the interview for both how to attack a problem and for actually implementing the problem. So I think that was well balanced. You had a good idea, you had good execution. That's a good thing there. We didn't get to ask you any more like like hard questions. So, that might be a stretch for you next time to consider, practicing some more hards. But for the medium
Yeah.
levels, I think you showed up pretty good today. Now, a
Cool.
couple things
Thank
that
you.
I think we can still talk about for sure is about, specifically. I mean, a couple things. The first thing is about a couple a couple ideas, a couple things you've said throughout the interview that are correct, but probably shouldn't have been said, or something you should have corrected yourself. So unfortunately, you already deleted this piece of code, but if you look at the remove function here, an example here is that you said it's in squared, right?
Yeah.
So now the reason I dug into this is because it doesn't have to be in squared. For example, you can iterate backwards in the array, and it would just be in, right?
True.
But when I asked about it and you explained why it wasn't squared, you were correct in your explanation. It's just that that's not necessary, right? So
Right.
I think this is probably a knowledge issue. Like it's a knowledge that removing items from an array should be O of n times the comparison cost. And the comparison cost for this is C, right? So this would be in, if you're being really pedantic, it would be n times C, right? But
Right.
most people call it just O of n. So I think this is something which you might just need to practice / memorize. You should just know that removing an item from a list or removing k items from a list is still O of n, basically, right? And so this is a bit that was like interviewers would definitely pick up on, say, oh, this guy probably doesn't know his list very well, even if you do,
I see.
right? So
Wait, so
go ahead.
about that, so what if like we had something like this,
Yeah,
right? Then wouldn't it be considered n squared?
yeah.
Even though
So
we moved this,
yeah,
we
great,
have to do it backwards.
great question. So the answer is still no. First of all, I love that you're calling this out, right? And the reason it's no is because you would actually just construct a new list that doesn't contain that word,
Oh, I see.
right? So you would iterate through the list. You would say, right? You would say, okay, I want cat. I don't want cat. I want cat. Don't want cat. I want dog. Let's add dog. Got beaver, right? Boom. And then you got AV
Oh,
for some reason,
okay.
right? And then you would use n minus k space, extra space, but it would still be O of n time. You see what I'm doing?
Right. Yeah. Yeah.
So regardless, like this is what I'm saying. Like this is just a like a coding pattern. If you're moving from a list, that's O of n times the cost of
Okay.
comparison, right? So
Okay.
so there's no reason it should be in squared. This is going to be a bit of a yellow flag, right? Just a conceptual error. Okay. So
Yeah.
just make sure you keep yourself like aware of that. And by the way, if you're asked about a certain thing and you realize you're wrong, just say you're wrong. Just say, oh, actually, no, I was wrong about that. It's actually like this. It's actually like that. Blah blah blah. Okay.
Right.
So just because to be honest, when the interview is asking you, they actually already know you're wrong. They're just trying to get you, like trying to give you a chance to correct yourself, right? So just make sure you pick up on that. Okay. There was one more earlier, but I forgot what that was about. I think overall though the problem was done quite well, and I will commend you again for saying or for in general being able to implement things pretty quickly. I think this is a very underrated skill, especially for the code problems that involve more typing, involve building out more code. So I think this is a great aspect, right? And in that vein, there's a couple of things that you can improve as well, right? So these aren't specific Leetcode skills, but I think are also quite important, right? For example, identifying when you're got duplicate code, right? When you got duplicate code, it's good to just refactor that out. Now, I'm
Right.
not saying the moment you got duplicate code, you have to factor it out. I'm saying you should call it out. Say, hey, Mr. Interviewer, there's a duplicate code here. Do you want me to factor this out? I can just keep it here, up to you. Call it out as an option, right? And if you're
Yeah.
tight on time, then don't do it, right? But at least show them that you're thinking about it. You know what I mean?
Yeah.
Okay. And then so that's one thing I'll say. And then another thing which I said, which I also said you think did quite good on, is that you were quite good at just sketching out the functions before you start, and also sketching out what helpers or functions you'll need. Right? I think the result builder was a great call. I think that makes a lot of sense. Now there are some downsides to that as well, which I would have liked you to explain or at least identify maybe some of the downsides of using a result builder, but I wouldn't say these were like major issues or anything. So, and I know we're a bit tight on time for the last bit there, so that's not like a make or break, definitely not. But again, it's just a general thing. Make the helpers when you need them. Call, like whenever you make a decision, call it out. Say, hey, I'm making this decision. I think this is the benefit. I think this might be the downside. Blah blah blah. And in general,
Yeah.
even if you're not completely correct on that, at least it shows the interviewer that you're considering these options, right? That that you're considering this and this. And also, by the way, when you're doing any sort of coding run like this, you can always say, hey, I think this option might be less performant, but it'd be quicker for me to implement. Would you like me to spend a bit more time on thinking of a better solution, right? This is always something you can call out, because oftentimes there's a lot of these downstream helpers or downstream effects which are impacted by performance, but aren't the intended test subject for the interview. So in those cases,
I
it's
see.
okay to like take a shortcut on the time or whatever it may be to to get to the more important parts of the problem. So always gonna be talking. Always just always talk. Always talk. Always ask. Worst they can do is just don't say anything and you just continue, right?
Yeah.
Um, okay, so and the last thing I'll say before I open up for questions for you is, the last question about the get minimum size group. So actually, my original follow up there was going to be the get the kth smallest group, but I thought that was a bit hard. Um, but actually, I think that would have been too hard because I think you would have definitely called out the heat being correct there, which I think is optimal. Um, whenever you're given hypotheticals like this, and this is not uncommon when people say, okay, well, how would you solve for this in that case, right? Always try to provide more than one option, right? So first of all, you said the heap. Heap is great solution, blah blah blah, right? And then say, oh, well, aside from the heap, we could be using this. We could use, oh, we could just use the same data structure. We could avoid using extra memory. We would just need to scan the anagrams dictionary every time we make a call. This will be a lot easier to implement, but it will be worse performance every time we have to make the call. Worse time performance, right? But all these kind of things you should be thinking about in terms of a time-space trade-off, right? So one way you can frame this is by saying, hey, with a heap, we would have a faster call to get the smallest group, but it would use more space, right? While if we were to scan the dictionary, we would, the call would be slower, it would use more time, but it would use no extra space. So for example,
Right.
if the function is called very rarely, then this might be acceptable, right? If the function is called very often, then it will likely not be acceptable, right? So this is
Right.
the kind of thing that you want to start talking about whenever you have the ability to come up with more than one option. So just always, again, just always talk about that kind of thing. It's going to be a really good look.
Okay.
All
Just
right.
in general, I need to think about the time and complexity and trade-offs more.
Especially for hypothetical questions, right?
Yeah.
And if you have the ability to come up with more than one solution, now I get it. Some people you might not come up with more than one, right? So then I have nothing to say. Work on that instead,
Right.
right? But if in this case you were able to come up with two. Now I did prompt you for the second one, but you can fix that, right? If you come up with
Yeah.
two, then you should automatically be thinking in your head, oh well, when would I use either one, right? When is the first one better? When is the second one better, right? Like did the comparison I give you there make sense for your example?
Yeah.
Right? So that is what I want you to say, right? I want you to say that next time. Oh, here's a heap. Here's what came to mind. Blah blah. Here's what's good. Here's what's bad. And we could also just scan the dictionary. Here's what's good. Here's what's bad. Right? That would be like a perfect answer in that case.
Okay.
All right. I'll pause here. I got some other notes I'll send you the notes after, but I'll pause here. Do you have any questions for me about either your performance today or about interviews in general? We can answer that right now.
Okay. So I guess first of all, you said to always be talking, right? But I think like during this mock, like there was stretches where I was mainly focused on implementation and like I
Yep.
was silent for like little stretches. Like, is that like a problem? What'd you say?
No, for today that's not a problem. I think your frequency of talking was fine. It's just that whenever like this applies more when in two places. First of all, if you're stuck, you weren't stuck today, so that's okay. But if you're stuck, that's when you really want to start talking about your thought process, about why you might be stuck, about what your current direction of thinking is, so the interviewer can choose to step in if they want. And the second aspect, which was a bit more relevant today, is when you have more ideas in the back of your mind, you want to voice that, call it out, maybe do a quick little trade-off comparison, and then keep going, right? So this applies when you have more ideas than you've said, right? More often than not always, but more often than not, if your ideas aren't horrible and they weren't today, you want to say them, call them out, and then continue. So that's what I mean by
Okay.
always talk about your ideas.
Yeah. Um, I probably should know this, but what was like the major issue with the result builder function in terms of like performance, like you said?
Yeah. So result builder, it's used in a couple places, and by the way, I'm not saying it's necessarily good or bad. This is something
Right.
which you again didn't directly call out, right? Is
Yeah.
that when you're doing the result builder, it's gonna be, I mean, two things. The first thing is you are you are making an implicit trade-off, right? The trade-off you're making is that you are now, instead of storing the old data structure, which would be in res, you're now storing a compact version in anagrams, right? Anagrams now dictionary, so it's more space efficient, right? However,
Right.
the issue is that you're making an assumption here. The assumption you're making is that that we're not going to be getting the groups very often, and that space is a very precious commodity, right?
Right.
So
Oh,
that
yeah.
so you're making that assumption, right? However, that might not be a correct assumption, right? It might be more correct, or not more correct, but it might be another option which you didn't check with me, right? It might be more correct. Another correct option to say, you know what, we don't necessarily need to save space here, and then if we don't save space, then the get group and get all groups function are much faster.
Right. Yeah.
So
I guess
this
it's
is
mainly because I didn't realize that you can remove from a list in event time.
yeah, that's
So
gonna affect,
it's
yeah.
like that. That's the trade-off, like faster removal or faster get functions.
Yeah, no, that's right. Yeah, so this is another thing, right? Yeah, you want to call out, and this is a lot more true for these class design problems where you have multiple functions to consider, right?
Yeah.
This is why these are a bit more difficult than just a one-shot function leak code things, right? So but these are things which, I mean, even if you were correct about the in square removal, these are things you want to check in with the interviewer, right? Say, hey, here's what the performance is going to be right now. Hey, if I implement this compaction, here's the new performance is going to be, right? Which one should I target? Is this acceptable, etc. Right? And now in this case, again, this is not a big deal. I'm just calling it out that I'm not saying your solution was wrong. I'm saying that I would like you to have a bit more analysis there. I would like you to talk about it a bit more, right?
Yeah.
But your analysis, given what you have written, is still correct. Like, you do save space. It does take more time, but you just didn't say it, right? So that's a bit of an
Yeah.
issue there. And then I mean, that's the main thing about the result builder. The code is correct, by the way. I'm not saying there's any bugs with it. The code is fine. Like, I'm not concerned about that aspect. So I think you did good over there.
Nice. Okay. Cool.
Cool. Anything else you have questions on?
Yeah, that was mostly it for now.
Okay, cool.
Oh yeah.
Yeah. In that case, I mean, yeah. Let me know if you have more questions on Discord. And
Yeah.
thank you for doing the mock interview.
Thank you. You're a great interview. Thank you.
Thank you.
Take care.
All right, we're gonna move on to the resume review. So I'm gonna how am I not logged in? So we're gonna go ahead and get that going. Let me remind myself, what account did I use for Figma again? Login with Google. I think I used a real account. Let's take a look. Yeah. Yeah, I would have actually asked a question about, instead of asking just to get the smallest group, I would have asked like get the kth smallest group, and then a heap would have been necessary, like required basically. Um, boom. Let me get the link going. Forms.google.com. There's also other harder, like these are all like, I would say, like Leetcode medium level questions. I did prepare a couple of hards as well. I mean, the thing about the group anagrams is that these questions can get really tough, if I want them to. So you guys can't sleep on Leetcode mediums like this. I might cook you. All right. Let's bump it back to like 8. All right. So the resumes, have fun. All right, T. Get jump scared. I'm out back a minute early today. All right. Let's see. We got 2 submissions today. It's good. Oh my goodness, it's been a month since the last time I last resume review, eh? Shit. It's been a while. Where is the download button? Okay, here it is. Boom. All right. This guy said. All right, what does this guy say? Okay, this guy said. Oh, nice. He wrote a lot. That's good. Targeting backend data eng for F26. Aiming for top 5 Canadian banks. Least a company at that level of the cycle. Then after my next co-op, my goal will be FANG for the following co-op. The goal of the resume is to present a hybrid suite profile. Prove that I can build, deploy modern web. Main differentiators: high scale backend performance, concurrent processing, distributed enterprise data. Took 800 apps interviews to my current co-op. I hope this will be a bit easier. 800 apps, 10 interviews. 80 to 1 is honestly not bad, I'm going to tell you. I'm going to tell you right now, that's already pretty good. So, could be worse. I've heard worse from a lot of people, unfortunately. Clarifications. First bullet point, my current job is present tense since my big co-op project we continue, blah, blah, blah. Also took over a project from another co-op representing, take over that plan, blah, blah, blah. Okay. Rest of bullet point, okay. All right, let's take a look. Let's take a look what's going on here. Okay, this is how much I expect people to write, and no one writes this much ever. I feel kind of purple today. Yeah, nice, okay. University, blah, blah, okay. Yeah, everything here makes sense. Okay. Architect. This is present tense, you're saying. Well, the present tense, there should be architecting, right? SvelteKit, Node, TypeScript, MySQL. Central application for tracking autonomous mining equipment. Okay. Engineered graph API stuff. Reducing load times 80% through SQL optimization, redis caching. Okay, this is good. I think both. This is a pretty good summary. This is pretty good. Reduce peak latency for 45 across 15 records. Python near Java, Python yes or button. Okay, cool. Yeah, this is good. I would maybe quantify, instead of using peak, quantify what this is. Like is this P99, P100, P95, etc. I think that would give this a bit more credibility. But I think data is still good. Engineer distributed geospatial interpolation pipeline, Databricks, Spark, SQL to synchronize truck telemetry with camera sensors, reducing variance by a percentage. Oh, okay. Geospatial interpolation data pipeline. Okay, this is great. This is good. I think this is pretty solid. This is pretty solid. Pretty solid stuff. I like that. Engineered high throughput Python pipeline stream process synchronized 19-channel site physiological telemetry. Low latency available. Okay. Okay. Sure. Architect. Okay, this is fine. These are all fine. I think the impact is a bit unclear in terms of how this helps the lab, but I think this is still fine in terms of describing what you've done. So I'm not gonna be too picky there. 3 projects. Robot stuff. Wait, what's the GPU for? The GPU is for a GPU backend. Oh, okay. This is pretty good actually. What is this? AI marketing platform, speech services, Webflow, Llama, RAG, Dockerized, Gene test. This is good. I think the points here are quite good. The project is kind of sus, but whatever. Economics and analytics platform. Okay. I mean, honestly, your points are good. I like the technology. This is all good. This is obviously your biggest piece, and you still got, until August, obviously. So I think over time you can probably put a couple more points here, expand upon them a little bit. These points can probably cut down to like 2 points. To be honest, this is a bit like this point is a bit mid. To be honest, the last point's kind of mid. Project points can start getting pared down a bit. You have some duplication. For example, you already talk a lot about CI/CD, Docker, GitHub Actions, JUnit, JUnit. Look, I like that you have it. Don't need to be on the resume. It's fine, right? So these 2 points are kind of the same. You could probably get rid of those two a little bit. So I think over time you can cut down the resume and then dedicate more points to your current experience, which is by far your most important one piece on the resume. I like the resume though. I think this is good stuff overall. I think you're in a good position, and 800 apps to 10 interviews is not bad. All right, this person said. Oh, this person also wrote a lot. Nice. Okay. Hello. I'd like to review whether my resume clearly signals I'm targeting general SWE, preferably back in infra, or reads too research ML heavy. Do my metrics feel inflated, too dense? Recruiter first pass. Appreciate quick look at whether my role and project title names are appropriate and effective. Should be rewarded. Also appreciate your take on one of my current two projects. Comment the research experience as well, or if something more traditionally full stack would strengthen the mix. Okay. On that note, two other projects swap in. One's a full stack credit score prediction app would deploy ML model built in AWS, Redis, Cache, and Terraform. Other CLI tool built for a part-time job uses XGBoost model to predict customer traffic for inventory. Blah 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 blah. Okay. All right. Please use line breaks next time. I like the writing, but you got to use paragraphs in your writing. I'm pretty sure my form supports paragraphs, right? Let me check. Where is my text? It's law answer, which I think means it supports paragraphs. So please use paragraphs next time. Okay. So here's your projects. Okay, right. You're worried about it being too heavy for research ML. Okay, let's have a look. Split that. Okay. Research developer. Okay, so immediately first point is a pipeline. So pipeline, network X. Wait, what is this? This is like okay. This is like okay. Modular benchmarking framework comparing simulation false medical imaging and automated. Okay, blah blah. That's good. Okay. So this is too much detail. No one cares. Okay. You can get rid of this detail. No one cares about that either. All right. What would I say? Yeah, definitely pretty heavy research ML for the experience. I don't know how much you could realistically change that, given this is what you've done. But I think what you could do at this point is put more weight on the projects. So let me see what you have on this front. Okay, demo very good. GitHub link very good. Good points. Full stack issue reporting service. Okay, optimize throughput, 25%, uploading compute heavy duplication. Okay, I like this. This is good. I mean, I don't know if this detail is necessary, but that's fine. Okay, and you have what other projects? You have full stack credit score prediction app with a deployed ML model. If you didn't train the ML model, don't put it on. The other is a CLI tool I built for my part-time job. Use XGBoost model to predict customer traffic for inventory and staffing decisions. Back-tested, known savings. Okay. So here's what I do. I will put that in. I wouldn't replace any given projects. What would I do? So what I would do is I would cut this entire point, cut this part out. And in this one, the first point is good. I would combine these 2 points into 1 point about performance optimization in general. And then, these ones could be cut a little bit. Let me see. This is good. multi-contributed research code base into modular Python packages. That's good. Implement distributed multi-GPU training, PyTorch. Are these two related using PyTorch? Let me see. What's going on over here? Okay, yeah. Honestly, I would just, I would cut this point. This point, unless something crazy was going on, I will cut that. I mean, if you built the networking itself, it would be good. But if you're just using Network X, it's just calling an API. It's not very hard. Yeah, I think given these changes, you can make enough room for one point for your CLI tool, and just focus in on how it's an improvement over the previous naive manual system. I think that would be a big improvement to your to at least that aspect. You know, it's just putting in more, like whatever you can, whatever data and information you can about non ML work. So I think just having that would be worth something. Okay, nice. Let's see. Any new responses? No, that's all so far. All right. Given that, I am gonna end the stream. Thank you for watching. Or actually, maybe I shouldn't thank you. You should